Hello, my name is Nick Guillemot. Welcome to my masterclass in dimensional modeling. I will be covering various topics, including canonical discussion of the various design patterns and methodology. Oh, and don't forget the like and subscribe thing. It really helps me out. In this episode, I discuss slowly changing dimensions, Type 4 and Type 5. It uncovers confusion over the purpose of what the dimension types are and how the methodology is for relational databases. WIKI needs to get its act together. While researching this series, I came across a strange definition of a Type 4 dimension. It described Type 4 as a history-only version of Type 1. As we'll see, that definition is not just wrong. In a relational database, it doesn't even make sense. That confusion may come from document databases that only look relational. For example, an order table might really be a collection of order documents. When an order changes, the old document is simply replaced by a new one. But dimensional modeling was never designed for that kind of system. It can still help organizing data, but its physical design principles are built for relational databases. And in most sizable organizations, the system that runs the business is usually the wrong place to do analytics. Analytical workloads work best on relational databases designed for dimensional analysis. Okay, so let's do a quick review of the basic slowly changing dimensions. Type 1 keeps current data only. It's compact, immediate, and simple. Type 2 keeps the full history of the dimension. It's complete, reliable, and well understood. Type 3 keeps some history. It's compact, but its memory is limited. You'll find those definitions almost everywhere. But Type 4? That's where the confusion starts. Back in '97, after Dr. Kimball's course, participants were invited to join an email discussion group. That group discussed the methodology, what worked, what didn't, and how to extend it. Over time, people proposed new ideas and practical solutions. That's when additional types started to take shape. We gave them descriptive labels first. Then, Dr. Kimball and his team summarized the results in design tip number 152, written by Margie Ross. That paper lays out the newer dimension types clearly. The key distinction is this. Types 0 through 4 describe physical modeling patterns. The higher types describe usage patterns layered on top of those structures. Before those numbers existed, we described the patterns in plain language. For example, what we now call Type 7 used to be described as put both keys on the fact. Once you separate structure from usage, the rest becomes much easier to follow. Type 4 is a mini-dimension. It takes selected attributes from a larger dimension and reorganizes them into a smaller structure, more useful for analytics. This is not just column selection. It is a regrouping of attributes into meaningful categories. The goal is to create a dimension that is smaller, more stable, and easier to query. A classic example is customer profiles. You may have millions of customers, but marketing doesn't analyze individuals one by one. Instead, customers are grouped into profiles based on behavior. For example, you'd have high-frequency buyers, discount-driven shoppers, infrequent customers, and so on. This produces a new dimension, customer profile, that is far smaller and more useful for segmentation. In this pattern, the fact table contains a customer key and a customer profile key. The customer dimension remains the detailed view. The profile dimension provides a simplified analytical lens. This allows you to build smaller, faster stars for specific use cases like marketing. Placing another foreign key in a fact table means that there's another surrogate key lookup. A way to avoid this is to store the extra foreign key on the primary dimension itself. In this case, customer segmentation is usually an offline process that reviews purchase history and assigns one or more categories to the customer. Those categories can and will change, and depending on your marketing department, they can change often. This is another reason why a mini-dimension makes sense. You isolate the volatile portion of the dataset to reduce the impact on higher levels of the user interface. Generally, it would only impact marketing, and they were the ones requesting the change. If the customer profile relationship is already stored in the main dimension, you avoid recomputing profile logic, you reduce joins during fact loading, and you ensure consistent key assignment. This simplifies pipelines and improves reliability. As you will see, this looks the same as Type 5, but the intent is different. In this pattern, the foreign key in the dimension is not for querying. It does not represent current state process and only exists to support data movement. There is only one valid analytical path, through the fact table to the mini dimension. This is not snowflaking. It is an ETL optimization. Type 5 builds directly on Type 4. It is not a new structure. It is a specific usage pattern designed for rapidly changing attributes. In a Type 5 pattern, the fact table references the main dimension and the mini dimension, but also the main dimension references the mini dimension as well. That reference is maintained using Type 1 overwrite behavior. This pattern gives you two ways to access the same concept. Through the fact table, you see the profile at the time of the event. This is the historical truth. Through the dimension, you see the current profile. This reflects the latest state. The same data, two different answers, depending on the path. This is useful when attributes change frequently. For example, we might have real-time scoring, behavioral segmentation, dynamic marketing classifications, whatever. Instead of consistently updating large dimension rows, those attributes are isolated into a mini dimension. This pattern introduces a snowflake. The main dimension references another dimension. This is a deliberate exception. It exists to balance historical accuracy and the easy access to current values. One of the problems with a snowflake is it breaks the primary query pattern. This results in more complicated queries. If the snowflake is exposed, users will mix current and historical logic, results will become inconsistent, and trust in the data will degrade. You can avoid these issues by creating a view of the snowflake. This way, users can continue to use the same basic query pattern. This pattern is powerful, but it should be used carefully, as it adds unnecessary complexity. Its primary purpose is to reduce uncontrolled growth on a dimension table due to frequently changing attributes. In most cases, a standard Type 2 dimension is simpler and safer. To summarize, Type 4 is a mini dimension. It's used to simplify analysis through grouping. Type 4 with a foreign key is used to support ETL and simplifies key management and does not change query behavior. However, Type 5 builds on Type 4 and adds a current access path. And the key idea is you have two paths. Through the fact, you get the historical truth, and through the dimension, you get the current truth. That distinction is the entire point of the Type 5. Thank you for watching. As you can see, time obscures the reasons why the dimensional modeling methodology exists, but we may also need to evolve and embrace new technologies as well. That is why I created this Patreon site to address dimensional modeling itself, as well as its application to alternative data structures. As a member, you can participate in discussions, ask questions, and influence others. Even suggest topics. Please. Your support will help me build a complete library of dimensional modeling principles and implementation tips I have learned over the past 25 years. Also, we may uncover new methodologies when dealing with non-relational sources. We will never find out unless we try. So join me. Become a member.